Hello, welcome to Unit 6 participation activity. We're going to do some comparison of two algorithms, the nearest neighbor algorithm, the minimum distance to mean algorithms. Now these are supervised learning algorithms. I know this is the unsupervised unit, but last week we did supervised, so I'm going to introduce this as we then move to k-means clustering for assignment 6. So I want you to open up this spreadsheet. There's an attached spreadsheet here. Now, if you don't have spreadsheet software, there's also a Google Docs version. So here's the spreadsheet. Here's Microsoft Excel version opened up. And here is the spreadsheet in Google Docs. You can use either one. Now, what we have here is a set of data. We have some labeled or categorized samples. So each column is a particular data set that or object we've measured and collected data on, and we've classified. And the first four are all classified as A's, and the next four is classified as B's. This might be, you might think of this maybe as people's faces. Maybe we have four pictures of person A, and for each picture we've measured different things on their face: the width of their nose, the distance between their eyes, the height of their eyes. So I have all these measurements on people's faces. So these are all person A's, and for each picture we've got 12 measurements for that person. So this is the measurements for one person, and this is the measurements for a second picture of that same person. And now here's person B. Maybe we have 12 measurements off of one picture. Maybe we have another picture, and we have 12 measurements off of that. And then we have person C. We have four different versions of person C and 4 different versions of person D. And they're similar. Person A, this first measurement is all about the same: 34, 25, 37, 33. In the same area, where in person B, maybe that person has a much bigger nose for measuring noses, so maybe this person has a 78. And so again, in different pictures it appears different sizes, but it's always bigger than person A. And same, this person C, has a relatively big nose. Person D has a relatively small nose. Now you could think of that as people and photos and measurements of their faces, or you could look at it other things. Maybe we're classifying forestry data, and these are all ash trees, and so we've measured certain things on 4 different ash trees. Maybe this is the circumference at 10 feet up, and this is the circumference at 5 feet up, and this is the circumference at 1 feet up, and this is the circumference at ground level, and this is the height, and this is the spread of the leaves. And so for each ash tree we've got different ones. And then maybe this is birch trees. So we have some birch trees here that we've measured, and maybe these are some cherry trees or something else. And these are, I don't know any D trees off the top of my head. Okay, so we have different measurements, and so we have these objects, and we have measurements on them, and we have them classified. But now we're going to get some new elements here. We don't know what they are, and your job is to look at this object and see, should this be an A, B, or C? What should we put up here? You might say, well, it's got, the first number is low, 28, and that's pretty close to either of these, so maybe it's like this. And the next number is low, and that's kind of like this. But this number is 71, and that's kind of like this. So again, you're going to try to classify, is it more like an A or a B? And so we're going to actually figure out the distance between this object here and each one of these to find that it's closest to one of these. Okay, I'm going to switch over to Excel and do this in Excel. So I'm going to look at this data. I'm just going to highlight this one tree here. And I'm going to compare it to this tree here, or person object. So I'm going to calculate the distance between here and here, the first X category. I'm going to take these things and copy them down here so I can see them. I'm just going to copy the labels. Let's see if I can do that. Okay, I've got my labels copied down there. And these are this is going to be the distances. You don't have to label all this stuff, but I'm just going to put it there so you can see. So how do I tell the distance between here and here? I'm just going to subtract 34 from 28. So I'm just going to say down here it's going to be equals this B8 minus this one, R8. So I've got B8 minus R8. And once I've got that, I can copy it down further here. So I can copy that function down. Now I notice that some of the times the values are negative. I don't like that. I want them always positive because again, sometimes this number will be bigger, sometimes this number will be bigger, and I'm just subtracting them. So I'm going to change my formula a little bit. I'm going to do, rather than B8 minus R8, I'm going to do the absolute value, ABS parentheses. So it's equals ABS parentheses and then B8 minus R8. So do that. So again, to do that here, I would just redo this. ABS parenthesis, click on X2 under the first data point, hit subtract, and click on X2 in the training data here. Again, once you have one of these formulas good, you can, in Excel, you can just grab this little box down here and drag it down, and copy and paste to get the rest of these formulas down. So I've got a whole row of values here. And so this is just all the distances or the differences here. And now I'm going to just sum those. So I'm going to do equals sum and highlight all this stuff. So I'm going to add up all these values to get a sum and 94. So that'll be my total, my distance. I'm going to compare, if I compare how far it is from this data point to this data point, it will be 94. Okay, and I'm going to do that for the rest. For the next object, I'm going to enter the formula. Now, if you set up these formulas correctly, and I'm just going to make one more change in this formula, I want to copy these formulas over, but I always want to keep this R the same. I'm going to go into my formula and where it says R8, I'm going to put a $sign right in front of the R. That'll fix the R so that I'm always in that column. I'm going to fix that. So it's equals ABS parentheses B8 minus $sign R8 parentheses. Okay, once I have that done, I'm going to copy that formula down to the rest of these rows. There. Now what I can do is I can just highlight this whole section here and copy this over. Now I'm just going to go to the start of my test data here and do that. So if I can check this, I'm going to go like right here in the column F. The column should say equals ABS F8, because I'm in column F, minus R8, $sign R8. Should still be comparing to this first data element. Okay, now this gives us my distances to all my values, and I want to see is this one closer to A's, B's, C's, D's. So I just want to find the smallest value. So I've got a 94, 71, 57. 57 is looking pretty small. I've got a couple 200s, more 200s, a couple 150s, 180s. So this 57, this is the smallest value. And that is an A. So I'm just going to put in an A up here. Okay? So I know that this one data element here is nearest to, which one did I say? This one right here. This one right here. Okay? So I want you to do the same thing, but now I want you to do it with this one and this one, so each one. So I can repeat this. This is 22, 37 here. So now I'm going to change my formula so that it's equal to B8 minus, instead of R8, I'm going to want this to switch over to S. I'm going to switch over to the S ones. So again, originally, let me change this highlighting back. So originally I looked at that first column, but now I've classified that. Now I'm going to look at this second column, and I'm going to redo my formula so it compares that second column. So now I'm doing the equal ABS of B8 minus S8 here. And I'm going to copy that down. And copy that over. Now when I look through my data, I've got a 61, a 94, here's a 67, and that looks like the smallest one here. No, I guess 61 is my smallest. So I classify this also as an A. So your job is to go through this and change your formulas and compare this to each one of these. Switch each one of these question marks to one, either A, B, C, or D by finding the value it's closest to. Now a couple caveats. In real minimum distance, or nearest neighbor, we should be calculating a true Euclidean distance, which is we would square these rather than do an absolute value. We'd square these, and then here, rather than just summing them up, we'd sum them up and then take the square root. But if we're just looking for the smallest one, this will work out just fine. Just taking the absolute values and then summing them up will give us the correct nearest neighbor for this. So that's all you have to do. I'm going to show you how to do minimum distance to mean also, and talk just a little bit about that. Okay, one of the problems with the nearest neighbor is that if we have lots of samples, we have to compare our unknown data element to every sample. So like if you're Facebook and you have 10,000 photos out there, people, when you have a new photo, you've got to compare it to all 10,000 or 10 million or 100 million photos out there that are categorized. So we're going to try to simplify it and make less comparisons. So what we're going to do, and again, you don't have to do this part, I'll just do this part. For all the A samples, I'm going to calculate an average A. So I'm just going to average out all the X1. So maybe this is the average width of this person's nose, or the average height at 5 feet up of this, or of this tree. I mean, circumference of this tree at 5 feet up, or something like that. I've got some, so I calculate an average here, just with equals average of these 4 samples. I'm going to do that for every of our characteristics, every one of our properties here that we're doing. And then when we calculate our distance, we're not going to calculate our distance to each of these neighbors or each of these samples, but only this one sample, the average sample. We're going to make an average sample. We're going to do that same over here. I'm going to do H equals average of these 3 B's. So the average nose size of the 3 pictures of B. Copy that down. And same here. Equals average. So in each case, I'm going to be calculating the average for each of them. So I'm going to make an average C and an average B and an average D here. And then, if I want, I could take this one uncategorized value and just compare it to the averages rather than all the samples. So sometimes to make calculations faster, we do this minimum distance to mean. But again, what I want you to do is do the nearest neighbor, not the minimum distance to mean. You just have to calculate that. So determine for all the unknown or the training data, you want to compare it to all the known data samples and figure out the labels and just attach that spreadsheet here. So attach this spreadsheet when you're done. So when you're done, you should have a spreadsheet, and in the training data, all the question marks should be replaced by either A's, B's, C's, or D's, seeing how close they are. Now, if you are good visually, you can almost recognize this from the data Notice here's all the A's graphically, and you notice all the A's start low, have highs, and then lows again, lows, highs, lows, highs, lows. And so this first element here we classified as lows, highs, lows. And the next one is lows, highs, lows. So it doesn't surprise me that these first two are classified as A's, because that's what A's look like. Where B's tend to start out as high, go down low, and then go high again and low as far as their characteristics go. But again, just looking at the graph is not very accurate, so we want you to do that with this spreadsheet and then submit that when you're done. Good luck.